The first law of thermodynamics says energy cannot be created or destroyed. For example, let's say we have some hot tea. We could arbitrarily say that the hot tea is the system and that everything else is the surroundings. According to our first law of thermodynamics, it says that the energy lost or gained by our system, which is the tea, should be equal to the energy gained or lost by the surroundings. Thus, if the tea loses 1 joule of energy, the environment has to gain 1 joule of energy. The second law of thermodynamics says entropy cannot decrease in an isolated system. We can essentially think of entropy as a measure of randomness or disorder. Let's look back at our hot tea example. It has this high concentration of energy, but as it cools down, the surroundings and the tea included go to this more disordered state. So the whole system goes to a more disordered state, confirming that entropy cannot decrease in an isolated system. Basically, the order at the beginning was the high concentration of tea. This was a very ordered state of energy. A more disordered state is when the energy is all spread out, which is what happens when the tea cools down and the heat goes towards the surroundings. This causes it to have less order because there's no more energy concentration. All the energy is spread out across the whole system. Thermal equilibrium is when the system is the same temperature as the surroundings. As time increases, everything tends to go towards a thermal equilibrium because this is a state of more entropy. For example, when tea reaches the same temperature as the surroundings, it reaches a thermal equilibrium with its surroundings. Basically, you can go from hot to cold, but you can't do the reverse because energy tends to go towards a more spread out state, more entropy.